Hello everyone. I'm Fabrizia, Della Penna. I'm from Italy, and I'm going to present today my thesis, which is called Towards a Green Digital Twin for Life Cycle Analysis and Building Renovation. So I would like to start with a bit of context, talking about the climate change. As we all know, this is a really critical global issue. For this reason, Europe is taking measures through the Green Deals of 2030 and 2050, which are involving a lot of sectors. Between these sectors, there is also the construction one, because maybe not everybody knows that only the construction sector accounts for the 30% of the global carbon emission. Of this 30%, then the 28% come from the operational emission, which are mostly the day-to-day basic emission of a building, and the 11% is from the embedded emissions, which are instead linked to the transportation, the production of materials, and so on. So since in the last year there was really important focus on lowering the operational emission. Now the focus is shifting into the embedded one, and this is done through basically doing a life cycle analysis of the materials used for the construction through their environmental product declaration. That are basically certified manufacturer documentation that include the CA. So basically we want to know in each part of the production, of the transportation, of the use and disposal of this material, how much is the impact that they have on the environment. In my thesis, the focus is going to the enhancing the interoperability between BIM and the LCA tools. In this case, we're going to use specifically Revit and one-click LCA. And what we want to achieve is as much as possible efficient data exchange between these two tools. Then from this, we want to even go further, introducing the concept of a green digital twin, which can help us to enhance even more the reliable and the application of CA analysis. This methodology was applied to a case of study, which is the rehabilitation of Casa del Capitano in Verona, Italy. This is a project provided by Copra Company in Milan. This project was a rehabilitation with the purpose of energy efficiency, and was chosen for this reason. First of all, because rehabilitation itself reduce the emissions, because it extends the life of a building and avoid the new construction. But we need to be careful on the materials we are used for the rehabilitation. So we focus on these materials, especially in this case where walls, doors, windows, ceilings, roofs, and floors. So the first part of my approach was started with a careful analysis of the model in Revit, and the first run of the one-click LCA tool with the plugin through Revit. I could see that there were some problems in the recognizing of the materials. So this was tried to be solved using a Dynamo script that was renaming the materials according to what the tool was asking mostly. And after just one run of this script, we could see that the improving of the material recognition was already great. So we keep going until we had a total recognition of the material automatically. So in this case, the Dynamo script make the process really more efficient. Then we wanted to basically go backwards. So from one-click LCA, since we had the materials linked with the APDs, we could download this APD from one-click LCA, and then through two plugins from the roots, we created some new parameters in the Revit model to allocate this data that were linked with another plugin from an Excel extracted from one-click LCA. So as we can see, then there is now we have in our model all the data about the EPD of the material And these data are not only making the model sort of repository for these informations, but also make basically bidirectional flow of data from Revit to one-click LCA that can be always updated when the conditions change, or the EPDs could change, or if you want to change the materials and so on. So basically, the results of this part of the analysis was for sure like an enhanced accuracy, because like we have flow data really that went really smoother. Automatic recognition of the data, because like a lot of materials were now recognized without any action. The possibility of optimization of the process through DynamoScript plugins and so on. And finally, this linkage between the EPDs of the material and the model in BIM. Of course, there were also some challenges because in the beginning, especially, there was a really big difficulty on the automatic recognition of the material name. And there were also some problem about the LCA database structure not being aligned with the granularity of the BIM model. So basically, some parts of the model itself were not recognized. And for sure, it emerged the missing of a standardized name for data and for materials and so on. So once we proved that the interaction between BIM and LCA is really proficient for the LCA analysis, we wanted to go even further. So basically, we understood that the LCA analysis usually are static, but the building is dynamic. So there are a lot of components of the building that are changing during the time. That can be the climate outside, can be the occupants' behavior, the energy production, the material production, and so on. So to consider these dynamic factors, we could use a digital twin, which is basically a virtual representation of a building that can be monitored in real time. To do that, basically we can monitor some variables that can capture the behavior of the building and of the materials, in this case, in all of the life cycle. So we proposed a theoretical framework that includes the use of sensors for indoor condition monitoring and of radio frequency identifier for the material. And moreover, we try to include some of these dynamic parameters that are changing, and in this case, we choose the energy mix shifting, since in all the countries we are going through shifting through the use of renewable energies to produce energy itself. So for what concerns the digital twin, basically we wanted to include the sensors that could control the performance of the building itself. This what can lead to the possibility to understand in the moment before the end of the life usage when a material has to be replaced, or how it is behaving, where can be like some damage and so on. This can be really useful, but to make this even easier, it would be really good to improve also the IFC schema, basically enhancing it with some new objects, attribute relationships that can make for us even easier to allocate this data from the sensors into the model itself. Then for talking about the dynamic data you were talking about, unfortunately, there are still no tools that allow to include this dynamic data. So what was our approach to see if these data are actually impacting the LCA analysis? It was chosen to use basically to do the same LCA analysis in one-click LCA with two different energy profiles for electricity, one from Italy and one from Spain. And Spain was chosen because the Italy and Spain are two countries kind of similar in climate and also in the energy production, but Spain is already more evolved in the use of renewable energies, and we think Italy is going to be in that direction in the next years. So basically, already changing this little data in our analysis, we could see that the impact of the building was already lowered, and that, of course, make clear that we need to include this data in our analysis to make them more reliable for the future. So, in conclusion, from all this study, what we understood is that, first of all, it's important to enhance the link between BIM and the RCA analysis, and that can lead to really better workflows, really easier, and make this analysis a part of a day-to-day practices in the offices and so on. Then that it would be really helpful in this way to have a standardized name for the materials and for the part of the building, because that will streamline the recognition of the materials. That is important also to include this information, this integration of the information from the sensors in one way, enhancing the use of sensors, and in another way, also including some new way to include this data into the model itself. And finally, that also the dynamic factor of a building are really important in doing an LC analysis, that it's actually accurate. And so it would be really, really important to include them. For future, so starting from this, of course, we would like to empathize like this real-time analysis between BIM and LCA. It would be, as I said, really useful to have these standardized names that can go between the designers, the materials producer, the EPDs producer, and so on. That the system needs to be a bit enhanced for these sensors components. And finally, to develop practical tools and practical framework to include dynamic data. Doing all of this, probably we will go into a more green future. Thank you, everyone.